Welcome to Master Mathematics in Minutes. Today's topic is the product rule of differentiation, and we'll cover a couple examples on how to differentiate polynomial functions. And we'll conclude the topic with a summary. And finally, be kind and subscribe for more videos. So, what is the product rule? The product rule states that for a function yx is equals to fx multiplied by gx, we have dy dx is equals to y prime of x, and that is equals to f prime of x multiplied by gx plus fx multiplied by g prime of x. So, the first step is to differentiate the first function, and that gives us f prime of x. And the second step is to copy the function gx, or the second function. And the third step is to copy the first function, or fx. And the fourth step is to differentiate the second function. And so that is the definition of the product rule of differentiation. So we'll have a look at a couple examples now. In the first example, we're asked to differentiate the function yx is equals to open brackets x squared plus 1 close brackets multiplied by x to the power of 3. So this function is a product of two functions. The first term is x squared plus 1, and the second term is x to the power of 3, and it's a product of these two functions. So we're able to apply the product rule to differentiate y of x. So we'll state the product rule here, and this is identical to what we saw earlier. So notice that fx is equals to the first term and gx is equals to the second term, and so we will write that or define it that way. So we have fx, and that is that fx, and we'll set that to be equals to x squared plus 1, and so with fx is equals to x squared plus 1, and with gx, which is that gx, and we'll set that to be equals to x to the power 3. And so with gx is equals to x to the power 3. So we've defined the function f, and we've also defined the function g. We'll then differentiate these functions. So starting with f prime of x, and that is equals to, we'll drop the power to the front, that becomes 2, and we will reduce the power by 1, so that is x to the power of 2 minus 1. And differentiating a constant always gives us 0. And that simplifies to 2x. And we'll then differentiate g. So with g prime of x, and that is equals to, we'll drop the power to the front, that becomes 3. And x to the power of 3, we will reduce the power by 1. And so that simplifies to 3x squared. And so we have all of the four terms, the function f, the function g, the function f prime of x, and the function g prime of x, which we can then substitute into the second equation to solve for dy dx, or calculate that derivative function. So what we've done here is we've stated the same formula again from the top. So we've stated dy dx here. So the next step is to then substitute each of these individual four functions, which we've calculated. So starting with f prime of x, we've calculated that as being equals to 2x, and so that is 2x. And gx, with gx is equals to x cubed, which we'll substitute as x cubed, or plus fx is this fx here, and that is x squared plus 1, so with x squared plus 1, multiplied by g prime of x, and that is 3x squared and 3x squared. So we've substituted these four terms based on what we've calculated here. And we will now simplify. 2x times x to the power of 3 gives us 2 times x to the power of 4. And we will expand the brackets, x squared times 3x squared, that is 3 times x to the power of 4. And 1 times 3 times x squared is 3 times x squared. And we have common terms here, x to the power of 4 and x to the power of 4. And so 2x to the power of 4 plus 3x to the power of 4, that becomes 5x to the power of 4. and we'll copy 3x squared down. So we've applied the product rule to differentiate the function y, which is the product of two functions, and the derivative of this function is given by this term here. In the second example, we're asked to differentiate the function yx, and that is equals to open brackets 2 times x to the power 7 plus 180, close brackets, multiplied by open brackets x to the power 5 plus x, close brackets. So again, this function is a product of two functions. We have the first term as the first function and the second term as the second function. And therefore, we're able to apply the product rule to differentiate this function. Again, we'll state the product rule for reference, and this is identical to what we saw earlier. So the first step is to define the function f of x, and we should set that to be the first term. And we have the function g of x, and we will define that to be the second term, which we'll now do. So we have fx, which is that fx, and we'll set that to be the first term, and that gives us 2 times x to the power 7 plus 180. And with g of x, which is that g of x, and we'll set that to be equals to the second term, which is x to the power 5 plus x. So we have the function f with function g. The next step is to differentiate these two functions. So starting with f, we have f prime of x, and that is equals to, we'll keep the 2 at the front, and we'll drop the 7 to the front, that becomes 7, times x to the power of 7 minus 1. And differentiating a constant is always 0. And that simplifies to 14 times x to the power of 6. And to differentiate g, we'll drop the power of 5 to the front, that becomes 5, times x, and we'll reduce the power by 1, that is 5 minus 1. And differentiating x, we'll reduce the power by 1, so x is basically x to the power of 1, and then we'll subtract minus 1 when we're differentiating. And that simplifies to 5x to the power 4 plus 1. And so with the function f, g, as well as f prime of x, g prime of x. So we will then substitute these four functions back into the second equation to derive the derivative function. So we have stated dy dx again here. It's identical to that equation there. What we will then do is to substitute each of these individual four functions, which we have calculated at the top. So starting with f prime of x, which is that f prime of x, that is 14 times x to the power of 6. We'll write 14 times x to the power of 6. With gx, which is that gx, we'll write that as x to the power of 5 plus x. And with fx, which is that fx, we'll write that as 2 times x to the power of 7 plus 180. And g prime of x is this g prime of x, which is 5 times x to the power of 4 plus 1. So all we've done here is to pull in what we've calculated at the top and apply that equation. Now, we'll then simplify. We'll expand the first brackets with 14 times x to the power of 6 times x to the power of 5. That simplifies to 14 times x to the power of 11. 14 times x to the power of 6 into x with 14 times x to the power of 7. And again, expanding the brackets at the back with 2 x to the power of 7 times 5 x to the power of 4. That gives us 10 times x to the power of 11. And 2 x to the power of 7 multiplied by 1, that gives us the same thing, 2 times x to the power of 7. And 180 multiplied by 5 times x to the power of 4, that gives us 900 times x to the power of 4. And 180 multiplied by 1 is itself, which is 180. And so there are common terms here which we can group. We have 14x to 11 plus 10 times x to the power of 11. So summing that gives us 24 times x to the power of 11. And we have common terms x to the power of 7, 14 of that, plus 2 of that, that gives us 16 times x to the power of 7. And we have 900 x to the power of 4 and 180. So that is the derivative of the function y. So in the third example, we're asked to differentiate the function yx is equals to 2 times x to the power of 10 times x to the power of 5. So again, this is a product of two functions. The first term is here, and that is the second term. And so we're able to apply the product rule. So again, we'll state the product rule. This is identical to what we saw before. And the first step is to define your function f and your function g. And so we'll set fx, which is that fx equals to the first term, and that is equal to 2 times x to the power of 10. And with gx, which is that gx, we'll set that as equals to the second term, which is x to the power of 5. So we've defined our function f and g. We will now calculate the derivative of these functions. So with f prime of x, we'll keep the 2 out. We'll drop the power 10 to the front. That's 10. And x to the power of 10 minus 1. We need to reduce the power by 1 when we're differentiating. And that simplifies to 20 times x to the power of 9. And differentiating g with g prime of x, and again we'll drop the power to the front, that becomes 5 times x to the power of 5 minus 1. Again, we're differentiating, so we need to reduce the power by 1, and that simplifies to 5 times x to the power of 4. So we have the 4 terms here, which we can then substitute into that second equation to calculate the derivative of the function. So we'll state the formula again. So dy dx is identical to that dy dx. We've just restated the same thing. And the next step is to substitute each of these 4 terms with what we've calculated at the top. So f prime of x is 20x to the power of 9. That's here. And gx, which is that gx, is x to the power of 5. And fx, which is that fx, is 2 times x to the power of 10. And g prime of x is that g prime of x is 5 times x to the power of 4, which is this one. And so we'll simplify that. We have 20 times x to the power of 14 plus 10 times x to the power of 14. And these two are common terms, which we can add, and that becomes 30 times x to the power of 14. So we've differentiated this function using the product rule, but there is an easier alternative solution here. So we could, for example, rewrite yx, which is the product of two functions, similar to that. We can expand the brackets and simplify that to be 2 times x to the power of 15. So then it becomes one term rather than the product of two terms. So we could then differentiate that single term, which is a lot easier to work with. And so with dy dx, which is y prime of x, we'll keep the 2 at the front. We'll drop the 15, which is a power to the front, and that is at 15 there. And x to the power of 15 minus 1. We're reducing the power by 1 because we're differentiating. And so that simplifies to 30 times x to the power of 14. So that 30 times x to the power of 14 matches what we've calculated before. Again, if you're given a function, it's always good to check to see if you can simplify it first before applying the product rule, because it may mean that you're able to arrive at the answer much faster this way. To summarize, the product rule states that if you have a function yx is equals fx multiplied by gx, the derivative function is given by dy dx is equals to y prime of x, and that is equals to f prime of x multiplied by gx plus fx multiplied by g prime of x. Thank you very much for watching. This is Mathematics in Minutes.